I'll hand the waiting room back to you. And thank you to everyone who has joined us tonight. So good evening. As I said, welcome and thank you for joining me. So first of all, I would like to acknowledge that we meet on country, and I pay my respects to the Darug and Gundungurra peoples, their elders past and present. So as Nikki said, I will be taking you on a journey this evening, and we're going to be looking at traditions in architecture from Asia Pacific, and exploring how we can use these to innovate our way into the future. We will have plenty of time at the end for Q&A, so please, if you have questions come up as you watch the presentation, just type them into the chat box and hopefully we'll get through all of them at the end. So first of all, I like to start by noting that our work doesn't exist in a vacuum, and it is informed by the work of many other people who've come before us, in particular people like Alexander von Humboldt, who was a scientist and explorer in the 18th and 19th centuries. He was a Prussian man, but he traveled through South America, and he climbed many a mountain wearing the kind of outfit that you see him wearing on the cover of that book. He was the first person to describe climate zones around the world. He looked at nature and understood it as a web of life. And he concluded through his firsthand observations that the way that humans were exploiting nature, particularly at that time through colonialism, was going to have a very big impact on the ability of nature to regulate climate. And so essentially he described the process of climate change about 220 years ago. Paul Oliver and his collaborators from Oxford, they have left us a legacy of in-depth research into the field of vernacular or traditional architecture. And this is where we look to for the evolution of buildings as well as enduring lessons that remain relevant for us today. So we use research in our practice to inform both the design process and the design outcome. In the first part of this talk, I'll be taking you through the places I visited during my Churchill Fellowship. So these were places that were both to the north and south of the 30th parallel. So that's the 30th parallel in the Northern Hemisphere. I went to Japan, China, and the Philippines. And as you can see, the reason for that is if you look at the 30th parallel in the Southern Hemisphere, you can see Perth, Adelaide, Melbourne, Sydney, and Brisbane. So the majority of our coastal cities are kind of clustered around that latitude. So there's very similar climate zones, and because we're both on the Pacific side of the world, the Pacific currents influence our climates. So I chose these places also because they have very long histories of urban settlements and have regularly been impacted by events such as high rainfall, flooding, high winds, monsoons, heat waves, and other climate calamities. We're going to look at 3 design principles: building form, building elements, and interface. And we're going to look specifically at design solutions that didn't rely on technology. Our first stop is in China, and we're going to be looking at building form. And what was interesting during my travels is that everywhere I went, I saw courtyard buildings. And this was fascinating because the courtyard building is actually a Persian invention. So Persia, old Iran, is a Middle Eastern invention. It was designed for a hot and arid desert climate. The courtyard or enclosed garden is also a spiritual idea. It's where we derive our word paradise. So what I saw is that the courtyard building has actually been adapted to suit almost every climate zone in the world. Courtyards are a way of organizing space. This plan is from a courtyard house in Beijing. So that's quite far north, and therefore it has long and cold winters. So you can see that the courtyards are quite large. There's more than one, and that's obviously to allow as much sun and heat to be captured within the spaces. The courtyard is essentially an outdoor room that's located inside a building. and it gives access to the outside to all the spaces around it. So every single room has got a kind of connection to the outdoors. It also creates layers of privacy. So as you move from the street into the house, you would have kind of more public rooms, a more public courtyard, and then more and more private spaces until you get to the rear where perhaps the master of the house and his wife would be living. So, you know, this in traditional society. So for example, in this merchant's house, which was under renovation, there are multiple courtyards. The one closest to the street, which is the one you see here, would act as essentially a public space. This is where guests and visitors would have been received, and people who you would not normally want to invite into the more private areas of your house. This is also where noisier or messier activities could take place without causing disturbance to the rest of the household. You have to remember that traditionally, and even today, households in China were multi-generational, so there would have been quite a number of people living in a large house like this one. This is an example of a skywell, which is a tiny courtyard in the kitchen of a much more ordinary workers' townhouse. It provides light and particularly ventilation to the kitchen area, so it would be able to remove all that heat that builds up when people are cooking. It also collects rainwater, so you can see here the floor has a little sunken area, and there's an opening in the floor, because traditionally there would be a rainwater tank located underneath for collection, and then obviously you'd have very easy access to water in the kitchen where it was most needed. Here you can see what happens when it pours rain, with the sunken courtyard collecting and dispersing the rainfall. The verandas around the courtyard provide an extra layer of protection for the external walls and for the internal spaces. Because the floor of the courtyard is sunken, there is a certain amount of freeboard provided, so it can mitigate flooding to some extent. Also, there's again an opening where the water would go down and then it would be collected underneath. And again, that would be for the immediate use of the household, but sort of thinking about houses as a system in a city, having every house with a rainwater tank that can collect water during a heavy rain. It means that the stormwater systems, the municipal stormwater systems, would then have a better ability to not be inundated at that time. So urban houses were generally townhouses, so very similar to our terrace houses in Australia. They're long and narrow, and they only had two external facades that would have had openings. But you can see in this diagram that by having an internal courtyard or atrium, these houses were able to be very effectively ventilated. Now we go to Japan to look at building elements. Traditional buildings in Japan are essentially a large platform that's raised up off the ground, a very heavy roof with large eaves, and then a lightweight infill with lots of movable panels which are multifunctional. So by moving these panels, you can set up different relationships between inside and outside. You can change the internal space configurations, and you can also adjust to external climate conditions. In addition to the sliding panels, there are things such as external rain shutters. In this particular case, these flip up and hook onto the roof. And then when there's a heavy rain or very heavy winds, obviously, you know, we have to remember Japan is in the path of typhoons. So when those kinds of climate events happen, then these can come down and they protect the building against those events. This is a townhouse that was renovated by the architect grandson of the original owners. And there are some later additions like sliding glass screens. So obviously glass wasn't in use widely in buildings until the 20th century, when it became cheap enough to manufacture on a large scale. And by doing that, this sets up a condition where you basically have two layers of sliding elements that can give multiple combinations of light and privacy to the interior spaces of these houses. On an urban and neighborhood scale, there are also elements which adapt entire streets. So in this photograph, you can see these movable fabric roofs. So they could be open and closed. And what that would do in the summertime, for example, they would keep the street very cool. It means that people could spend a lot of time outside. People lived in small houses, so public spaces were really important. That's something we've learned through the COVID period, the ability to use a public space. So these elements would keep the streets cool, people could spend time in them, and they could also spend more time in the shops. So there was a kind of economic benefit to it as well. Typical of Japanese ingenuity, they have accommodated many elements in a small area. So all the letters that you see in this drawing are basically movable and changeable building elements. They allow the occupants to adjust the building to the sun, heat, rain, wind, privacy, and security in multiple combinations. So it's really clever design, compact, and specific to places where you don't have a lot of space available to do these sorts of things. Our final stop is in Vigan. Vigan is a Spanish colonial town in the northern part of the Philippines, where traditional buildings of timber and bamboo were adapted by the Spanish with their own traditions of brick and stone. The prevailing climate here is primarily one of heat and humidity, large rainfalls, and again, typhoons, and also they are subject to earthquakes. So the buildings kind of had to take all of these things into account to last as long as they have lasted. Typical of Spanish colonial buildings, the outer walls are right on the boundary of the property, and basically the buildings form the street edge and the public spaces. Particular to Spanish buildings in the Philippines, they incorporate very specific solutions to interface with the climate that we don't see in other places where the Spanish colonized. So for example, externally, the openings are protected from the sun and rain. Either they have very large roofs that cover with the eaves, or as in this photograph, they have individual hoods that protect each window. You can also see this decorative pattern on the roof eave here. And what that is a punched out section of the roof eave that allows air to be sucked into the roof cavity. And what that does is it pushes the hot air out of the roof cavity and therefore keeps all the spaces within the building much cooler than they would otherwise be. From the outside, the houses look very solid, but internally they are like light boxes. They've got these massive openings that are almost floor to ceiling, and they create a complex interface between inside and outside. There are 3 to 4 layers, all of which slide past each other, and they can be adjusted for ventilation. Yeah.
Sorry to interrupt. You're just breaking up a little bit with your audio. Maybe if you turn your video off. I know we'd all like to see you, but often for me, I've found that the sound is then clearer when.
Okay, I'll try that. Thanks,
okay,
Nikki.
Good stuff. Thank you.
Thank you. Okay, sorry. So there's 3 or 4 layers that all slide past each other, and they can be adjusted for ventilation, heat, glare, views, and privacy, and they also incorporate local building materials. These are some of the most comfortable houses I have been in under hot and humid conditions. And it's really impressive, especially when you consider that these houses were built about 450 years ago. So that's a really long time for these techniques to demonstrate that they, have longevity. So I'm going to show you some projects that have adapted these traditional design principles into contemporary houses. But before I do that, I want to just touch briefly on the idea of the 2030 house. So this is an idea that came about from research conducted by the Design Council in the UK. And they went out and asked a cross-section of people what was missing from their own houses or the housing choices that the marketplace offered them. The first thing you'll notice is that this is not very much about solar panels and rainwater tanks, but it's thinking about sustainability as a much broader idea that targets many important issues. So for example, homes that work well, homes that are easy to adapt, that respond to climate change, places people can share with others, places that are multi-generational and multifunctional, attractive and innovative. I found this vision really interesting because it kind of crystallized a lot of ideas that we float around with clients when designing houses. So let's look at some recent projects and see what's possible. The first example that I'm going to show you is a typical pair of side-by-side inner city terraces that have not so typically been combined into a single residence. They're located in a heritage conservation area, as many of these are. So from the outside, they look much the same and maintain that nice character that the streets and neighborhoods have. On the inside, they have been almost entirely reorganized. The front rooms are retained as individual spaces. They can be configured as family areas or as home offices. So that idea that people should be able to work from home, which we have all found out through recent experience, has become really important. The rear studio can be accessed either from the laneway or from the rear yard. So it could potentially be used by a member of the household, say like a university-aged child or a grandparent, so that you could have multi-generational living in this house, or it could be completely separated and rented out for additional income for a period of time. So as I mentioned, the front rooms are more traditional in their proportion and character. They can be used in flexible ways, either closed off from or combined with the main living areas. The two rooms are interconnected, so they could work together as a large office or study area, for example, or they can be completely separated from each other, and each room then functions independently. So you could have one as a home office, the other one as a library, TV room, or as a guest room. Whatever the needs of the family are at a particular time could be accommodated. On the first floor, the children's rooms are designed as a series of spaces that can be configured as 3 individual rooms, as a 1+2 combination, or as a one large space. For example, if the kids are all getting along with each other, they can have the doors open and they can share one large space. Or if they have friends, family for a sleepover, you know, you could have 10 kids sleeping on the floor and they would all be having a great time. On a daily basis, as the kids get older, and they are going to be wanting more privacy from each other, then they can decide to separate the rooms via the large sliding walls that come along those two sides. Because the rooms are quite narrow, the beds are built as window niches, so that keeps the floor free for play or for adding a study desk and other furniture as the kids get older. Within the bed niche, each child can adjust the environment to suit themselves. And we think that this is important, that children learn how to use buildings and that they learn how to make themselves comfortable within buildings. So each one of the bed niches has got an operable window, and it also has a series of internal screens that the kids can manipulate themselves. A unique aspect of this house is the internal atrium over the living space. So going back to that idea of the courtyard, in this particular case, it has sort of been reconfigured as an internal atrium. The atrium works to modulate climate year round. It incorporates movable elements so that the building can adapt to the climate. In winter, it captures the sun and it allows that warm air to sit in the house, and as the warm air then rises, it takes that warm air through to every room at both the ground level and the upper level. In summer, the atrium can be opened, it can be shaded, so there's no heat gain from the sun, so the house stays cool, but it allows the cooling breezes in the afternoons generally to be opened up. And again, every space has the ability to be effectively ventilated. The other aspect of the atrium is that it brings light into what would normally be the darkest area in a terrace house. There are two elements within the atrium that move independently: the sky window and the shading screen above it. So the space can be manipulated to go from completely enclosed to partially open, partially shaded, unshaded, to completely open. It controls light, shade, heat, and airflow. But more importantly, it connects the building and the people in it with nature, the sunshine, clouds, the starry night. I want to take a couple of seconds to make a little announcement here, because I know that there are people who worked with us on this project who are attending this presentation. So if you'll all indulge me for a second, I just found out a couple of hours ago that this house has been shortlisted for the National Sustainability Awards. So I just want to say congratulations to the whole team and well done. This next project is a typical workers' cottage in the inner west. It's a much smaller building type. It's a house for a retired couple. So they obviously spent lots of time at home before all of us were forced to do the same. And I'm sure many of you will relate when I say that social dynamics, not getting in each other's space and being able to do, different activities at the same time were really important considerations for this couple. This is a house that's organized around 3 gardens and 2 entry points, with the original bedrooms and the private areas retained towards the front of the house, and then the new living, kitchen and dining towards the rear, each with its own garden outlook. The rear garden had a couple of existing mature trees, which were obviously retained, and then they become the backdrop for the living areas. So from inside the living spaces, you are always surrounded by greenery, whether you're looking outwards or up through any of the openings, your view is always to something that is green and natural. Looking in the other direction, you're connected to the courtyard. So there's still light and effective ventilation coming into that space, and you would also have a view to the sky. The courtyard is what connects the old and the new, and it has a dynamic element that allows adaptation over the days and over the seasons. The courtyard also serves as a secondary entry. So for example, if you had guests coming and you didn't have time to tidy up your bedrooms and you don't want people walking past them, you can ask them to come through the side entry, and that becomes like the party entry. This also makes the house accessible because there's a ramp from the side passageway up to the courtyard level. And once you're up at this level, you're basically at the level of the house, and there are no steps internally. So that's a really important consideration when people are thinking about aging in place, and you have different mobility requirements as you get older. The courtyard has got 2 large doors that can be positioned to direct the flow of people, as I just mentioned, as well as the flow of wind. So this could be partially open to the rear garden, or it could be enclosed for complete privacy and security. This is what it looks like from the inside. And if you don't have your own sun-facing brick wall, you just borrow the neighbors, you block the wind, and that's where you have lunch during winter time. The eating kitchen is separated, but it's still connected to the courtyard and to the living area. So the 3 spaces then can function together or separately. They can be covered or uncovered. They can be enclosed or open. There's a few elements that give multiple combinations to create flexibility for daily life and adaptability to climate conditions. This last project, is located in the Blue Mountains. So that's quite a different climate from what we have in Sydney. is both much colder and hotter. It's more extreme. You get anything from 40+ degree days in summer to snow in the winter. And in this case, the idea of the courtyard is manifested as a roofed outdoor room, which separates the house into two different wings. And the way the house works is that each of these wings can be compartmentalized, essentially, from the others. So when you capture sunlight and heat in the summer, each of these spaces can heat up and retain that heat. But in the summertime, you can open up the entire house, and because of the way it sits along the hillside, it can capture the cooling breezes, and then you're basically using that free energy to cool the space. So the living area this is what it looks like when it's closed. So that would be separated from the outside, but then it's connected to that outdoor room through a series of sliding elements. So by opening it up and then closing a screen, a multifunctional space. So it can act obviously as an extension of the living space, but it also is its own room. And in summer, for example, it could be an overflow sleeping space. So if you had lots of friends who came over for a weekend because they wanted to go bushwalking, you'd have somewhere to chuck your friend at night, and it would be comfortable. There wouldn't be any flies, no mosquitoes, but nice cooling breezes, and it's a great place to stay. So it's essentially, it works as a space that allows the house to expand and contract depending on climate conditions. So I'm just going to touch briefly on some metrics for the 2030 house, which are related to energy and electricity use. I'm sure there's someone in the audience who loves numbers and has been waiting for this. So the first thing that I like to say is that we really start by considering how to make use of free energy. And what I mean by free energy is, if you hear architects talk about passive design, that's what I'm talking about. It's knowing how to use the sun and wind to provide heating and cooling at least part of the time during the year. Then we have to minimize energy requirements. And the way we do that would be through things like high insulation values, the quality of detailing, incorporating building science, and the quality of building construction. So that's where you really get efficiency gains. So essentially for houses that we design, this is on average a 50% reduction on electricity consumption. And that's just purely through design techniques. Once we've done that, then we look at generating renewable energy. This is generally done through solar panels, but it could also be done through other systems like wind or biomass. If you do renewable energy together with design, then we can easily generate 100% of the electricity requirements of a house. It's not a problem. And quite often, we can actually generate a surplus of 10 or 20% of electricity requirements. So you're basically making more electricity than you require. And you can either store that in batteries, or you can sell that to the grid through a feed-in tariff. The 2030 house metrics, which is this little diagram at the top, is talking about more than electricity. So it's talking about total energy use. So for most people, that would mean electricity plus other forms of energy like gas, or if you're in the country, that might be, wood burning elements like biomass and things of that nature. So the idea here is that it's looking at all the energy needs of a house. So that's lighting, heating, cooling, hot water, power, etc. And as you can see, what we're trying to do is move from a current benchmark, which is quite high, to something that is approximating zero or is very low energy consumption for any given size of house. And the other thing that I'll point out is you can see many of our houses already meet that 2030 metric. So it's clearly something that's within our reach to be able to build places like this. It's not as hard as it looks. So what is required? How do we get there? As usual, the first thing is probably a mind shift. We have to think a little bit different than we're used to. We have to think about sustainability in a more comprehensive way so that it includes both people and nature, and it gives them equal emphasis. So not people over nature or the other way around even, but an equal emphasis of people and nature and understanding that relationship. We have to incorporate flexibility and adaptability to mitigate how climate is changing and how our own lives change over time. We have to create an effortless experience for the inhabitants. So it should just be really simple and really easy to live in a house that uses these sorts of techniques. We have to integrate technology with design to achieve those high efficiencies. They go together, it's not one or the other. And finally, and perhaps most importantly, we have to consider buildings in relation with people and in relation with their environment. So not looking at buildings as static objects that we look at, but buildings as dynamic systems that can last the test of time. And lastly, I want to say I don't do any of this on my own. If it wasn't for the talent of my partner, Ken Ye, many of these ideas would never see the light of day. And also our team of builders at ShoreBuild, who have worked on every house that I have shown you, and many specialist craft people and tradespeople who work with us, and they're instrumental in making these buildings possible, in sharing the values and the agenda and the effort that it takes to do something well. So I want to just extend a thank you to all of them. And I thank you to all of you for joining me tonight. And I think I'm right on time for some questions now.
Fantastic. Thanks so much, Carol. I think we're all ready to move into these houses. They look amazing.
Thank you.
So we've got a few questions that have come in already. One of them was about the sliding panels that you had, I think, in the first room. That was in the first house, sorry, that was from Paul, just what they are made out of.
Okay, so they're actually just very large doors, and they're made as solid door panels. So we just found the biggest possible doors that we could make. And so it's not a super customized kind of building element, because one of the things that we try to do as much as possible is to incorporate building techniques and building materials that are readily available. Obviously, sometimes, like with the Sky window, it's a very custom-made element, but a lot of other times we just try to use things that are off the shelf. So those are just very large sliding doors, but they're solid so that they really act more like a wall, and they, you know, because they have to give some acoustic privacy as well.
Yeah, great. Then there was a question from Anne. She was wondering whether the skylight could get damaged by hail.
So the skylight actually went through a hailstorm. I think that was last summer after the bushfires. We had hail, as we, you know, tend to do, and there was absolutely nothing wrong with it. So no, the skylight is actually engineered, and the type of glass that it uses it's quite a high specification of glass, but it is hail proof, I guess you would say, because that was one of the first questions my client asked as well.
Yeah, I bet. Then Anna asked about concrete and alternatives, particularly for flooring, as eco alternatives?
Yeah, so concrete is, it's a bit of it has a lot of advantages and it has a lot of disadvantages. So the kinds of strategies that we try to use is to obviously minimize it as much as possible. Sometimes you need a concrete structure for other reasons. In particular, like in the terrace houses, it actually kind of holds the walls of the terrace houses together because the foundations of a lot of terrace houses are so poorly built. So it actually had a purpose beyond its environmental qualities of being able to hold heat. That house that I showed in the Blue Mountains doesn't have any concrete. The entire house is built with lightweight materials. And this was one of the reasons that we did that, was because we really wanted to try to build a house that had the same environmental credentials, but didn't utilize the concrete as a way to hold heat in the space. So we did that in the Blue Mountains house. So there's definitely ways that you can get around it. You can use, kind of insulated floor panels. You have to understand building science to know how to incorporate other elements within the building, such as phase change materials that then take the place of the mass that the concrete would be providing, because thermal mass works both for heating and cooling. So there's a lot of science behind the way that these buildings are built, but it's definitely possible. And that's, I think, what we wanted to show with the house in the Blue Mountains, that it's definitely possible to build an entire house with quite extreme changes of climate that doesn't require concrete as a material. And, like in that house, you would normally have temperatures that are between 10 and 15 degrees, either cooler or warmer than the outside temperatures. So that demonstrates that it can be done.
Yeah, fantastic. And I suppose also, having a well insulated shell makes such a difference. So if you do need to provide some heating or some cooling,
you've got to hold it in.
Keep it in.
If you don't have insulation, you're basically heating and cooling a sieve, and it's a complete waste of effort. So that's why I mentioned, building construction and detailing is actually key to energy efficiency. Without that, you're kind of going round in circles and you're not really having any gains.
Yeah. So then we've got a question from Vivian, just wanting to get an idea about how much time to allow to get from sort of the first concept to a design that meets energy objectives.
The design process is usually, I suppose, it's not the longest part of a project. Usually the building part of it is. And I think in terms of the design process, what we encourage our clients to do is to take their time during the design process, because you are being you're being given a lot of information and a lot of new ideas, and you need time to digest that. So I would say if you give yourself something like, a good 3 to 6 months, then you have the opportunity to have a really intensive dialogue and to ask lots of questions and to understand the physics and the science behind what you're trying to do, if you're working with an architect who does that. So it's important that you spend more time at the beginning to get those things right, rather than try to rush that and then perhaps make some wrong decisions, and then that's going to be additional time at the end. So I would say somewhere around 3 to 6 months. Obviously, I don't know how big Vivian's project is, so it's hard to say, but for a typical house, it would be something like that.
Yes, Vivian, if you're as indecisive as me, it'll take you a year for a deck. But you got to get it right.
Definitely, you got to get it right before you build it.
That's it. Then we've got a question about what you would say would be the most important sustainability measures, sort of the order of importance within a design. What's the most important? What's the least important?
I'd say the most, if you're building a new building, or even if you're doing a renovation, the most important things are the things that are the most difficult to change. So those are the things that you have to, have really intensive conversations about with your designer or your architect. So things like orientation, things like where you're going to put windows, the things that are structural, the things that are really hard to change are the most important things. The things that are really easy to change, like a tap, they're the least important, because you can buy the wrong tap, you can change it 6 months later, but you can't change the orientation of the building. That just takes an enormous amount of effort. So I would say just think carefully about what is like from hardest to easiest, and concentrate on the hardest things first.
Yeah. Then we've got a question about using plants to keep the structure cool during summer, like wall gardens, rooftop gardens, those sorts of things, and also generating your own food at home. Just what your thoughts are on that.
Yeah, I think it's a fantastic idea. That first house that I showed you, the terraces, they actually have 3 green roofs, and part of the reason for that is to keep the spaces inside cool. It provides additional insulation. It can help to hold some of the rainwater that falls on that roof. So again, it's that idea that you're not overwhelming the stormwater system downstream from you, and that you're basically kind of regenerating the water cycle within your property. And it also has one of the green roofs is specifically for food production. So it's a place where the kids hang out with their friends after school. So it has a social dimension as well as, an obvious kind of you get food from it dimension. So I think all of those are really good options. I would say with green roofs, as with any garden in Australia, you want to be really careful about what you put there. You want to make sure that, you are guided by someone who has experience and knowledge in native gardens, who can choose plants that aren't going to use tons of water, that aren't going to die when it's really hot or really dry or very rainy, because that we live in a climate that has these extremes by default, and those extremes are only getting bigger as the climate changes.
Just on that, we've just got a question from Amanda, just about what is innovative in water storage compared to 10 years ago.
What is innovative these days? Actually, there's not much that's innovative in water storage compared to 500 years ago in some of those houses that I showed you at the very beginning. I think some of the innovation that's coming out is obviously in the systems that can clean water to a standard where it becomes drinkable, which hasn't been possible for some time, or hasn't been allowed from a health and the utilities perspective. So like New South Wales Health hasn't allowed people to drink their own rainwater. So there's some technological advances, but otherwise it's a very simple system. It's a kind of foolproof system, and I don't really understand why, unless you have really, really high space constraints, which some houses do, it doesn't make sense to me that you would be building a house without a water storage system, because particularly even if you only use it for your garden, it's still worth it. We've just gone through a number of years of water restrictions and watering gardens, and people's gardens die. So that kind of ties in with the previous question about green roofs, etc. Like these sorts of things go together, because if you have a green roof, then you need a water supply. So if you have the rainwater tank, then you can make sure that your green roof is always going to be healthy. If you're growing veggies, then you're going to have they love rainwater much more than they like tap water, and your veggies are going to be organic and better tasting.
Fantastic. I think you've got a client here in Paul who I can't wait to hear more, Paul. He's building a 100% off-grid sustainable house in the heart of Crow's Nest. So we can't wait to come and visit. Awesome. And we've got a question from Yanni just about the cost of designing and building a sustainable house, and that it does, it seems costly when you're thinking about custom made and those sorts of things. So just if you can comment on that.
Absolutely. So I can tell you off the bat that it doesn't cost any more than any other architect design house. Obviously, architect design houses cost more than a project home. So generally, we tell people to budget somewhere around $5,000 a square meter is a kind of average number in the Sydney area. It could be a bit less. It could always be more, and it could be lots more. And that really depends on your needs and your wants and how much customization you want to include. So like the first house I showed had quite a high level of customization, but the second house, the smaller workers cottage, didn't have such a high level of customization, and it was a much smaller budget. So there's quite a range in budgets, but what I think the main takeaway is that it doesn't cost any more to do these things that I am talking about than if you just had an architect design house that was just really nice but didn't incorporate any of these things. And so I think that's really important to keep in mind. And the other thing to keep in mind is, how much cheaper it is to run these houses. So if you have a 50% saving in electricity, up to 100% saving in electricity, that's money that is flowing in your direction as opposed to out of your pockets on a daily basis. And that's important because generally the cost of running a building can end up being almost as much as the cost of building the building over the life of that building. So running cost is also a very important consideration when you're talking about cost. And if you are building a house for yourself, one would assume that you intend to stay there for a certain amount of time. And so you've got to think about how you're going to pay for it over time.
Okay, I've got another question here. I've just lost my place a little bit. Oh, apartments, that's right. There's obviously a lot of apartments popping up all over the place, particularly, on transport corridors and North Sydney, as well as other areas. Are there any plans for 2030 buildings, apartment buildings, and what can be done in apartment buildings to improve their sustainability?
Okay, if there aren't any 2030 plans, then there should be, and there's no reason why the kind of 2030 ideas can't apply to almost every kind of building. And apartments they have their own efficiencies, obviously, because they efficiently use space in some ways much more than houses, but they can have their inefficiencies if they're not well built. I think with apartments, we need to understand that is a model that is a successful way of urban living. It's not going to suit everyone, and people still need to have choice. And if you look back at the 2030 house ideas, having choice in the types of housing was one of the key requirements. So having lots of diversity in the housing market and the types of housing typologies that exist is important. But apartments, particularly along transit corridors, is a very sensible thing to do because you're building density in those places, you're encouraging people to use public transport, you're minimizing car use. Car use is another major contributor to greenhouse gases, so you're minimizing that. And again, many of these ideas can be incorporated into apartments. There are apartments already out there, like in France. If you build an apartment building, you have two options. You can have a green roof, or you can have solar panels, or you can have both, but you can't not have either. So there's no reason why a lot of these ideas can't be incorporated into apartment buildings, where people could have rooftop spaces that are shared outdoor spaces. They could have greenery in those spaces. They could have energy generation that at least covers part of the energy requirements for buildings. Apartments have a lot of different energy requirements than houses because they've got a lot of emergency lighting, emergency equipment that has to be on 24/7. So there's kind of a different consumption pattern than people in houses. You can incorporate, rainwater tanks in apartment buildings. You can incorporate ways of the apartments themselves being more adaptable. So internal spaces don't have to be broken up into all individual rooms. There could be these kind of flexible spaces where people could have, a 1+2 kind of apartment setting. I think the difficulty is obviously that apartments like project homes are kind of thought of as a product, something that a developer packages up and then is selling to you or selling to the marketplace. And we have to find a way to incentivize these kinds of solutions in apartment buildings. But technically, there's no limitation to any of them. I just think that apartments, usually they're kind of playing catch up a little bit in terms of innovation and their sort of lag and what the marketplace requires. But if there were apartments like this that had some of these techniques and that had some of these strategies incorporated, I think a lot of people would be drawn to them who might not otherwise be drawn to them. So you're actually kind of widening that market appeal to people living in apartments.
Mm. And while on apartments, I need to give a council program a quick plug. That's the Future Proof Apartments program that looks at existing our existing stock and working with residents and strata groups wanting to improve the energy efficiency and energy generation of their apartment blocks. So check those out if you're living in North Sydney. In a strata building. Okay, we are rapidly running out of time. We do have some more questions. I don't know if we'll get to all of those. There is a question about using water storage as thermal mass, and also sort of a cost-benefit analysis on material selection for the Blue Mountains house in particular.
Okay, so water storage as thermal mass, theoretically that works because water is a thermal mass, and that's essentially that's why the climate, if you are near the harbour in Sydney, you get a much milder climate, so you don't get the big swings in temperature because you have this large water body sitting next to you. The sorts of projects where we've incorporated water in that kind of with that kind of idea has been to actually use swimming pools as heat sinks, or swimming pools, located so that they could be incorporated into a kind of cooling system into the space. Other than that, then when you're talking about using a water body as thermal mass, it becomes really complicated because essentially in a building, what you're trying to do is keep the water out, not in. So having a large tank of water somewhere in your building needs to be very carefully thought through. And it may not be the most effective way of doing it. So I would say it's kind of technically possible, but realistically, it hardly ever lends itself to being the best solution. So it's a bit difficult to say without kind of having a specific example, but as sort of conceptually, that's how you would think of it. And then in terms of cost-benefit analysis for materials for the Blue Mountains house, obviously when you're building in the Blue Mountains, you're building in a bushfire zone, so that's a consideration that sometimes takes precedence over other considerations. And you have a BAL rating and you need to meet that BAL rating, and part of that is through the materials that you use. But we did look at things like we used a particularly a system of foundations that are sort of big piles that go into the ground, and there's no concrete that's poured. So we looked at the cost-benefit analysis between those. So the foundation system for that house was done in 1 day. whereas if we had done a concrete foundation, it would have taken weeks. And so obviously there's an obvious savings just in time and labor in using that system, the piling system versus the concrete system. Now the piling system is very unusual for a house in Australia. Most people don't use it. It's used for commercial buildings, and it's actually used for solar farm installations. So it's kind of atypical. Nevertheless, it doesn't mean, you know, that you can't use it. It's just most people don't know about it. So there were systems like that. We also used a prefabricated system for the flooring, for the floor structure, and that allowed us to very quickly, within a couple of weeks, get the whole floor platform built. And then the builder had some, you know, flat areas to be working from. And that's a particular consideration of working in a sloping site, where you actually all the time you're trying to get something flat. Tools need to sit on flat surfaces, etc., and it just makes it much easier to get a roof on top of your head, and then you're working within a more protected space. Again, that's also a consideration of the climate. It's quite hard to build in the mountains because the winter is quite long, and so that makes it more difficult for construction purposes. So there were a number of elements of the building where we did that kind of cost benefit analysis, and that was part of the decision, part of the considerations that led to a particular decision. But as I said, there were other things like bushfire considerations that led us to, you know, particularly with exterior materials, had to be non-combustible. You want things that, you know, you can put on, and like if it does get damaged, you can take it off. It doesn't require maintenance. There's no painting. It's sort of self-protected. All of those kinds of considerations had to take place as well. Yeah.
Thank you so much, Carol. Thank you so much for sharing all of that wisdom and knowledge, and I'm sure many of us have been scribbling busily. So yeah, just a big thank you to you, and congratulations on your award shortlisting.
Thank you very much.
And just to everyone else, keep an eye out for an email from Jordan just with an evaluation for tonight's session. And thanks everyone for joining us, and have a good night.
Thanks everyone. Good night, everyone. And good luck.
Okay, bye-bye.